Problem number 54. So we want to prove the following two statements. The first one, 2 to the power 41 minus 1 is divisible by 83. And then the second one is this expression is divisible by 13. So let's start with the second one. So we know that 13 is a prime number, but at the same time it's like 4 plus 9. It's like 3 square plus 2 square. We are going to use that property. So if I rewrite this expression as 2 square to the power 35 plus 3 square power 35, that gives me, so like if you open the parentheses, you have 70 here, 70 here, and then open and like calculate the squares. That expression is basically this. So now, as we mentioned in one of the previous problems, since we have the powers are odd, we can factorize this expression. Write it as 4 plus 9 multiplied by some expression here. So this one is, so basically this expression is 13 times some x. So it's a multiple of x is divisible by x. The formula is the following. When you have an plus bn, so you can look up this formula. You can, if n is odd, so we are going to use this again and again, maybe. So like remember a cube plus b cube formula. So this can be rewritten as minus n minus plus a n minus 3b square and so on. So that's the formula. But the idea is the first term. So 3 plus 4 plus 9 is 13. So this entire expression is 13 multiplied by some number. So that gives me that this expression is divisible by 13. Now let's move to the first one. The first one is, in fact, so like 83 is a prime number. So this 83 is a prime number. And this is actually looks like a part of Fermat's theorem. So like since this is prime number, 83 is prime. Using Fermat's theorem, you can say that 82, 2 to the power 82 minus 1 is divisible by 83. So if you factorize this expression 2 to the power 80, so it's like it becomes like 41. So it's a difference of squares because it's an odd number, even number. 241 plus 1 is divisible by 83. So which means this one or this one has to be divisible by 83. So that's the idea in this problem. So what we want to do is just try to find what's the remainder when 2 to the power 41 is divided by 83. So you can look at this problem as this: 241 mod 83. What's x? So what I'm going to do is try to replace to make this number smaller. I can rewrite it as 2 to the power, for example, 2 to the power 8. 2 to the power 5 is, okay, 2 to the power 8 is a good candidate for me because 41 is again prime number. So let me write it like this. So what we have is 8 times 5 is 40 plus 1, 41. And 2 to the power 8 is 256 to the power 5 multiplied by 2. So what happens if you divide this number by 83? So you will get, so if you divide, you will have 3 and the remainder is 256 is 3 times 83 plus 7, so remainder is 7. So you can, this number is in terms of remainder, it's congruent to 7 to the power 5 square. So I'm replacing this with 7. Then so let's split this 7 cube, 7 square by 2. And that number is, if I rewrite it here, so let's move, so like this is 343 multiplied by these two is 49 times 2 is 98. So replace them by remainders. What's the remainder when 343 divided by 83? That should be, so 343 is 83 times 4 plus 11. So 11 multiplied by, if you divide 98, that the remainder is 15. So you have this. And when you multiply them, you get 165. Or that's equivalent to, if you divide 165 by 83, that remainder is 82. So when you divide 2 to the power 41 by 83, you get the remainder 82. So if you add 1, to this number, you get 241 plus 1 is divisible by 83. So there is a mistype probably in the statement of the problem. This one has to be plus. So 241 plus 1 is divisible by 83. So we had only two options in the beginning, by Fermat's theorem. And the idea is to find which one of these two numbers is divisible by 83. So 241 plus 1 is divisible by 83.